Lesson 1-6 is relations, and the objectives in this lesson are to represent relations and interpret graphs of relations. The Algebra 1 standards involved with this lesson are A1.3.4 and A1.9.8. So let's look at some definitions to begin with. First of all, we have the definition of relations. A relation is just a set of ordered pairs. In ordered pairs, we're talking from the coordinate system of x's and y's. And we are going to talk about some other vocabulary called domain and range, which you guys should already know. The domain is the set of all first coordinates. And I've got X in parentheses because once in a while they'll throw in A's and B's or M's and N's or something like that. But generally, for the most part, you can think of it just as the X's. Domain is the set of first coordinates. Range, the set of second coordinates, which are the Y's. Now, I want to mention something about the domain that might help you remember which one's which. When I hear the word domain, I think of the word dominant. And when I think of dominant, I think of somebody that's a leader or kind of overbearing or maybe in charge. And really, if you think about graphing points, isn't the X in charge? Because everything depends on X first. It's the leader. You always do the X and then you do the Y. Anytime that you deal with an equation, it's y equals, but it always depends on that x. So x, set of x's are the domain. They're kind of the dominant ones. Domain are the x's, y's the range. So we're going to look at a relation. It's a set of ordered pairs. Notice it in set notation there. The four ordered pairs, 2, 1, negative 3, 2, 2, 4, negative 1, 1. We are going to take that relation and represent it all the ways that we can. So the first way of representing that relation is in a table. So in a table, it can be either vertical like the one shown here, or it can be horizontal, but the columns or rows are separating the x's and y's. And you just take the points one at a time and place them in the table. So 2, 1, you would put that in the table as 2 under the x and 1 under the y. Negative 3, 2, negative 3, 2, 2, 4, negative 1, 1. So we have completed a table with that relation. Next, on a graph. It just means taking those 4 points and graphing them together on the same graph. So 2, 1, you always start at the origin and you always go with the y first. So 2, 1 would be right 2, up 1. Negative 3, 2, it would be left 3, up 2. 2, 4, right 2, up 4. And negative 1, 1, left 1, up 1. Okay, just to clarify, when you are graphing, you do the x first and then the y. So for the ordered pair 2, 1, I went right 2, because that was the x, and up 1. On negative 3, 2, you do the x first, the negative 3, so left 3, up 2. 2, 4, and negative 1, 1. You always do the x first, then the y. Okay, so mapping is something new for you. Here's how we do the mapping. You're going to start with the domain. The domain is the set of x's, and I'm going to kind of refer to this table to help me. I can just look down that left-hand column and see that my domain, see how it's 2, negative 3, 2, negative 1? What I'm going to do is I'm going to list my domain from least to greatest, and you do not repeat any numbers if there's a repeat. So I'm going to say -3, -1, and 2. That would match writing the set of the domain, naming them -3, -1, and +2. You do not repeat, and you should list them from least to greatest. I'm going to look at the range. That's looking at the y's, and I'm going to put those in order from least to greatest. 1, 2, 4. Again, you don't repeat any, and you put them in order from least to greatest. So range, 1, 2, 4. This is how you do a mapping. Mappings always go from domain to range, from left to right. So I look at my first point, 2, 1. So from 2, I draw a little arrow up to 1, just like that. -3, 2. So from -3, I draw an arrow down to 2. Two, 4. So from 2, I draw an arrow over to 4. And -1, 1. I draw an arrow from -1 to +1. That is a mapping. That is a mapping. From left to right, you draw arrows from the domain to its matching range. That's something new for you. Are there any questions about doing a mapping? You have them in ovals, the domain on the left and the range on the right. Put them in order from least to greatest, and you draw arrows from left to right. So we will be able to take any relation and write it as a table on a graph, a mapping, and then be able to name the domain and the range. Okay, continuing on. Let's look at some more vocabulary. Now that we've talked about domain and range, there are some things you need to know and how they're named. There is always going to be an independent variable and a dependent variable. The independent variable is the boss. Independent. They don't need anybody else. They can take care of it themselves. That goes along with domain, doesn't it? Being the boss. The independent variable is always the one on the x-axis, the domain. Independent variable. Dependent variable. It depends upon the independent. It is limited to what it can be. It depends upon the independent. Y always depends upon X. So Y is the dependent depending upon the independent, which is the X. All right, they're going to give you some scenarios, and you have to identify what's independent versus dependent. And if you had to put them on a graph, the independent would be along the x-axis and the dependent would be up along the y-axis. So the example B, the number of calories you burn increases as the number of minutes you walk increases. The number of calories you burn increases as the number of minutes you walk increases. So, what is the boss? What does one depend upon? Do the calories depend upon the minutes walked, or do the minutes walked depend upon the calories? Which way is it? My tree, what are you thinking? The minutes walked are independent? Yes. So definitely you would do minutes would be independent and the calories would be dependent. I'm going to tell you kind of a little secret. If you can't tell, almost always, this one's an exception, almost always the first thing that's listed kind of is independent and the second thing's dependent. But this one is pretty clear because you would have to understand the calories are completely dependent upon the minutes. So if there's some that you can't understand, usually the first thing is independent, but not always. This one's turned around. Okay, last but not least, we are going to look at a graph and see if we can describe what is happening. So let's look at this. When you read a graph, you always read it from left to right. And this one says Ms. Ling's classroom on a winter day. Ms. Ling's classroom on a winter day. So what you do is you read from left to right. So this corner would be the beginning of the day. And then it would go over here till the end of her day. So that's time. This being the temperature up the left-hand side, and it's really not going to give you actual markings. It's just going to do things in general. So at the beginning of the day, the temperature starts here, and what happens to the temperature? Right at the beginning of the day, what happens to the temperature? Zach?
It goes up.
It goes up. And it goes up for a little bit, and then it all of a sudden goes down. And then it goes up and down and up and down and up and down and up and down until finally at the end of the day, it goes down. Can anybody understand what is happening to the temperature in her room on that day? Zach, what would you say?
I'd say that's when people are coming in and going out of the room.
Okay, so you think it depends upon people going in and out of the room. When people walk in and out, that changes the temperature, do you think?
Yeah.
Okay.
Because, the hallway has different pressure than the pressure inside the room. That's why your doors are shut if you open a window, because it changes the pressure in your room rather than the pressure in the hallway. So the pressure in the room may be higher than the pressure in the hallway.
Well, all of that is probably true. I'm with you. It changes, and yes, true. But I'm not sure that just people coming in and out will change the temperature. I do know that if a lot of people are in a small area, yeah, it seems like it makes it warmer in there, and that is exactly right. But I'm thinking just in general at the beginning of the day, let's say when I come in at 7:30, let's say that's the beginning of my day, and I would say this part right here might even happen before students come in. So that might not be exactly what we're getting at here. Jared, what are you thinking?
Probably at the beginning of the day when they first turn on the furnaces, our heat will screw up. And then as time goes on, it gets colder on the system.
Okay.
And at the end of the day, we shut the furnace off and the product is running off.
Okay, that makes a lot of sense. So at the beginning of the day, the heat, the furnace kicks on to start heating the room, and then it kind of fluctuates, and then at the end of the day, it's programmed to go off because there's really not people in the building. There's no reason to waste that heat. Does anybody understand the thermostat setting in your house? Anybody understand that thermostat setting? If your house is set on 70 degrees, how does that work, Jake?
It's set on 70, and you have it depending on hot or colder, it'll turn off, and then once it starts to go down, it'll kick back on.
Right. So if you have it set on 70 and it's hit 70 degrees, it can read that temperature, feel that temperature, and it hits 70, then your furnace goes off. And then over time, the temperature is going to go down because that furnace is off. But when it goes so far down, it's programmed to come back on. And then it'll put out heat. That's why your furnace runs. It'll put heat out through the registers until it gets to your temperature of 70, and then it'll go off again. and it'll be off until that temperature, it's eventually the cold from outside or just that it's not been on, the temperature goes down. Once it gets a certain spot, it goes back up again. So here's what you would need to do. So the furnace turns on at the beginning of the day, increasing the temperature, and then it fluctuates.